Hello, everyone, and welcome back to Math Deciphered. Today, we have a very special guest with us, Dr. Asad Sahir, a distinguished chemical engineer and professor at IIT Ropar. Dr. Sahir has a unique perspective on the intersection between mathematics and chemical engineering, and we're thrilled to dive into his journey, insights, and the incredible impact of math on chemical engineering. Dr. Asad, welcome to the conversation.
Thank you, Tejas, and it has been a pleasure to follow your seminal efforts in having these interactions, catering primarily to people who are aspiring for a career in math and how it can be made more accessible, especially to students in STEM. So thank you so much.
Of course, it's an honor for us. Your primary focus is chemical engineering. Could you share how mathematics might have sparked your interest in this field, chemical engineering? Was there any, particular moment or project of inspiration when you realized that mathematics plays a pivotal role in all engineering fields?
Thanks, Tejas, for the question. So to begin with, my interest in chemical engineering essentially started by just having a look on the Dorling Kindersley books, which were colorful books having colorful pictures on chemistry. And then when I came across the pictures on nuclear reactor, I did have a sense in my mind that how these units are built, where these fascinating reactions happen. This was about class 8, and between class 9 to class 12 I was introduced to chemistry and was particularly interested in physical chemistry to begin with, and a particular textbook on chemistry, a general chemistry by James Brady, which introduced the factor label method and showed that how it can be used to understand general chemistry concepts, build the foundation. When it comes to mathematics, Tejas, in India, I did my schooling in class 11th and 12th. And we have this, the time is around 1999, and we have this culture of having coaching centers. I took at one time, a coaching class on trigonometry. It was for 2 months. The class was fascinating, but somehow I felt that uh, I was not feeling benefited, because what used to happen was that the teacher used to discuss problems on a sheet of what we call thin rice paper, put the carbon sheets between them, the carbon paper sheets, and then used to just write the notes. But there was no active engagement nor an understanding that how the different mathematical principles work. So that was the only coaching class which I took. And then I said no to coaching. And then I studied on my own and fortunately got selected in one of the engineering examinations. The journey then began with that the mathematics teachers which were found were not that motivating, because then it was all about abstract differential equations, surface integrals, volume integrals. So there was a loss of interest. But what particularly sparked my interest in mathematics was my chemical engineering professors, particularly beginning with Professor Shaukat Ali, who taught us fluid mechanics. When he taught us the fundamentals of fluid mechanics and the effect of differential equations, and particularly a subject which is called transport phenomena, and gave that introduction to us, that how we could apply the laws of conservation of mass, momentum, and energy, and identify these general equations. Then the tie between engineering physics and mathematics became quite evident to me. And that's really sparked out a very fascinating journey to begin with. But the key idea that I wish to explain in my answer is that there may be moments in a scientist's career where you don't get the maths teachers that you really are looking for. Sometimes you have to wait, but do not lose hope, do not lose confidence. If you are working hard, life will provide you an opportunity.
Okay, that's wonderful to see, how you started with like coloring books in chemistry, and then you were first interested in physical chemistry. You also touched upon how mathematics plays a pivotal role in chemistry and physics. And you spoke about how, there might have been some teachers who, like lessened your interest in math, but also your chemical engineering professors brought back your passion for it. And we'll definitely touch upon those questions later on in this interview. So, over the course of your academic journey, how has your perception of mathematics evolved, especially in its applications? We spoke about the applications of math in chemistry and physics. So, can you discuss a specific instance where, you used mathematical inspiration to solve an engineering solution problem?
Yeah. Thanks, Tejas, for the question. My undergraduate preparation was done at Aligarh Muslim University. Got an idea, but the real source of, I would say, the aha moment came during my master's thesis when I was solving a problem which is called solid state fermentation and trying to model a reactor. The way to do it is that if it's a large fixed a reactor which is operating at an ambient temperature where you have dumped in some biomass and there's fermentation which is occurring. To solve that set of a reactor, essentially you have to model it. Yeah, so you don't take the volume as a single entity, but you have to partition it into some slices. And each slice can then be solved with the help of a differential equation. So continuing on the same thought, so I had a professor, Professor Surendra Kumar, who taught us modeling of chemical ring systems, where there was an intersection between what is happening in chemical processes, particularly chemical reactions, biochemical reactions, how to separate components, and its tied with chemical engineering concepts and mathematical concepts, like introducing us matrix methods, introducing how to formulate these systems. And given the two backgrounds, that gave the necessary foundation in order to solve such problems. And this was about 2003. So you had to the use of computers in India was evolving, and there was a package to which I was introduced was called MATLAB, Matrix Laboratory. Not many examples in MATLAB were available at that point in time in chemical engineering. It was primarily as a package which was being used by electronics and communications engineers. Coded the first on how to solve simultaneous ordinary differential equations in MATLAB through whatever examples were available, trying to break the problem down. So there was mathematical as well as computational insight, which was developed during my master's thesis. Another source of inspiration, so this was the deterministic side, the stochastic side of the story. Another professor, that is the time that I got my first math professor, Professor U.S. Gupta, who instilled a lot of confidence by explaining that how statistics and probability should be understood. So he used to explain each and every example very clearly in a lucid manner. And that is where I have developed an interest in understanding that how a good mathematics teacher can essentially transform the course of engineering or your study in a career. So good math teachers are, I would say, a must if you want to really do good. So if you're, I would say, a person who is listening to this podcast thinking about, and I will discuss in detail from historical evidence also, not in my case, but others where mathematics teachers have really played a key role in accelerating careers.
Okay, so you first touched upon your fermentation project and how you used modeling to like implement math into the project. So you d divided the volume into different slices and then used differential equations to solve it and develop the model. And you also like were introduced to MATLAB, right? So that's how math was inputted into your project. So you also touched upon the importance of a good teacher and how they can build your confidence, right? So let's build up on that. So reflecting on your own educational journey, can you discuss the impact of a specific mentor or a teacher? And were there any specific qualities or teaching techniques that they used, which, like made them who they are, made them such a good teacher or mentor?
Sure. So I'll just begin with my experience first. So how do people have approached in chemical engineering the mathematical derivations? So the first thing is that have the opportunity for the student to reflect upon what is happening behind an equation. So a differential equation is not the solution of a differential equation or the solution of any mathematical method is just not understanding the steps, doing the mechanics. But if we can give it a meaning, if we can give it a reflection on how it is applicable to the real world, where the real world applications are, and so the thing becomes a little bit less abstract but more meaningful. When I after this was because since I didn't have a good math teacher, so I've been always curious to understand and what are the qualities of good math teachers. And a few examples come to my mind. So one is Mrs. Beulah Shoesmith. This is she was a teacher in the 1920s, 1930s. whose work is really fascinating because she was in the Hyde Park School in Chicago, and under her tutelage were two National Medal of Science winners and the famous Nobel Prize winning economist Paul Samuelson, who did remarkably well in laying the foundation of econometrics in the 1960s. And they were her students. And when I look upon their articles and their reflections, they explicitly mentioned that it was Mrs. Beulah Shoesmith who helped us develop a mathematical insight, which proved us very valuable in career. And these are articles, and I'll be happy to share the Tejas and the links below below this podcast. They are gems in terms of acknowledgements that how do teachers play an important role. Even when I was preparing for this talk, I just wanted to know a little bit about Mrs. Shoesmith. So there are some articles in the mathematics teacher where she's making a case that how our education systems are not focused, and this is 1930s. This is an article from the 1930s that were not focused on teaching the brightest pupils. So, she discusses a few strategies which are very fascinating. The first thing that she says that often in the classroom, the focus is on getting the pass succeed with the grade, with a passing grade. So your focus is lost from the brightest students. So how do we encourage those brightest students to achieve those big things? And I think that whether it's the United States or in India or any part of the world, those insights are still valuable, like having graded assignments, having mathematics clubs, and promoting that love for the subject. And that had a significant influence in having Nobel laureates and Medal of Science winners, National Medal of Science winners in the United States. So just imagine that how significant an impact the person would have had. Another instance, when we look onto Richard Feynman. So Feynman Richard Feynman from the historical anecdotes we learned that used two textbooks on how a practical way to learn calculus. I recently downloaded those books, and then I see that the earlier you are able to relate the mathematical concept with the physical insight, and these are wonderful texts which were written in 1910s and 1920s, they give a very clear illustration. The third example is Albert Einstein, whose uncle Jacob Einstein did refer when they were studying algebra. That algebra, you have to, it's just like a merry science, and then just think the variable x as if that you are chasing a thief. So the earlier these people, if got these insights, what I learned very late in my life, they make a significant difference. So teachers are extremely important.
Okay, yeah, that was wonderful to hear. You spoke about those three examples, and you also touched upon economics and econometrics, right? And I think that math again has a lot of applications in economics. I think it just shows what a versatile subject it is. So um, let's move on to the next topic, which is about self-doubt. So throughout your career, how have you dealt with moments of self-doubt, particularly when, like, for example, you were stuck on like a hard engineering or mathematical problem? And what personal strategies or techniques did you use to boost your confidence and come out of the feeling of self-doubt?
So the self-doubt, I think in class 11th and class 12th, when I was doing a lot of self-doubt because there were sometimes in examinations I was not doing as good as I was achieving academically. But it was my father who was a professor in geography who encouraged me that Asad, just believe in yourself and this day will pass. If you have to become a researcher, you will not get the opportunity in life to go through a solved example. Have the habit to study. Although he never studied mathematics as a discipline, and never solved a differential equation, never solved a matrix method, he did some statistics, but he valued that the importance of self-study. And my parents, my elder brother, who was also doing so, I have a family. My father was a geographer. My mother was an entomologist. My brother also did bio, but nobody had across last 10th. A few engineers in the family, but to come across to a journey like PhD, it was those basic moments that there were times where you had to realize you had to take a score, and then you had to have that belief that things will be fine one day. And because you have researchers who always encourage that, okay, you have to learn the basics, you have to learn the fundamentals. And if I could have dropped out of math at any point in time, but it is just moments that is that the moments that happen in a person's life is that you have to keep your calm, keep on working, be confident. And another thing which in the Indian education system, which I feel very strongly, is that because of these competitive examinations, the amount of knowledge which is being expected that you have to learn in 2 years is far more beyond than the human mind can really comprehend. That is why we're having these coaching classes. And if we give our students the flexibility that sometimes some students will take a little bit more time. Even the competitive examination is not the end of the world. But what we really need as a country, as a society, are people who can just hold in on there and be patient. Another thing which I learned in the United States, and I would advocate very strongly, is having very good libraries, having variety of books, because there are very good authors in mathematics, and every learning style is different. Some people may like to go very advanced. Some people would like to go from the fundamental basics. So, an investment in libraries, investment in learning resources, which are accessible to class 11th and 12th children, is a great asset. And I think that is something that I really admire wherever governments have invested in public libraries, because then the student has the opportunity to look at a book, look at various perspectives on learning a subject. And I think that is extremely valuable.
Yeah, I agree with you on the concept of self-studying. I think that reading a lot on your own will definitely develop your knowledge. I think it's like very important not to just like limit yourself to what you're learning at school. And if you're passionate about something, it's important to read more works and, like broaden your knowledge of that subject. And in the like speaking of the concept of, like overworking the students by as you said, like studying more than the human mind can capably, like the capability of the human mind for 2 years. I also think that it's important not to overwork the students, and they should like continue having their motivation for mathematics or whatever subject they're pursuing. And I feel like these competitive exams brings out, like the ones who have the most resilience, because your motivation is just going to last for like a certain amount of time, but it's like only a few students can push through and like make it to the end of the journey and do well in these competitive exams. So yeah, so let's move on to the next topic, which is about your students and colleagues, and how do you build their confidence, especially in areas where they might feel they're less capable. Can you share a success story of someone you've mentored who has become successful through your guidance and who overcame significant challenges through resilience?
Teachers, there have been numerous students, but teaching philosophy primarily has been that I focus a lot on helping my students understand the topic. And there was an advice which was given by a famous professor, my dad's mentor, whom I met at the University of Minnesota, that the job of a teacher is essential. Job of a teacher or professor is essentially to train students how to think. So, as when I'm introducing a concept, I try my best to inculcate that where the applications are, how to interpret the various facets of a figure or a diagram, how to read through the equations. So, I'm more focused on developing those fundamental concepts, because if I can get the students at the earlier stage, the advanced concepts, the student can pick them up. But when if it's just like building a building, if the foundation is weak, then the building is weak. But if the foundation is strong, and even if a person is able to work through the first and the second floor, the student can do on his own, because the passion is there, the interest is there. Oftentimes, what happens is that we have a tendency, that is what I've noticed in certain academics, that may not be focused on the student, but may be focused on to showcase that how well they know a particular subject. So they think that, okay, that if I'm introducing advanced concepts, forgetting the student behind, the student will not respond, but you could see that they are losing an interest in the subject. They are not taking it forward. in their goals and aspirations going through. Particularly in the application of mathematics, I believe that the one aspect is practice, but also you have to motivate the student to do practice. And then there should be a diversity of problems. Some would be explored by the students, some where teachers could have a discussion. Another technique which I have used quite a lot is inculcating the habit of group study. For full disclosure, I never did group study, but I felt that when it comes to engineering, then a lot of things happen when you are studying in groups, especially using your study units, your study circles. Sorry, if you have an opportunity to have be a part of a study circle, then students can teach each other very well. They can help understand, clarify the concepts. So, as if I may say, an academically inclined student may motivate a less inclined student, and so the entire community rises and gets inspired. So that is something that I really try to leverage when it comes to also interdisciplinary courses. So, for example, in the current course, I may have people from bioprocess engineering, from chemistry, from in this particular subject, they're from chemistry, bioprocess engineering, and chemical engineering studying in a similar group. Then I would devise group assignments so that different disciplines interact with each other, and they also develop a camaraderie also. This I've done in my current course in process system engineering. I've done in statistics and chemical engineering, and introducing them with the analytical as well as computational tools. I have tended not to make the course structure too advanced when it comes to giving a lot of concepts, because it may make one's work easy, but I would like that I can have the majority of the class, those who are invested in the class, are learning along with me. So the focus is on the learner.
Okay, yeah, I understand what you're saying. So to sum up, you think it's you said that it was important for the professor or the teacher to like maintain or if not increase the passion of the subject for the students. And also you said that there's no point just like adding on to knowledge if the student doesn't understand the basics. It's most important to, keep your foundation solid and understand all the basics before learning new topics. So let's move on to the
Yes, and
next.
I would also, Tejas, I just wanted to mention
Yeah,
one
of
more point,
course.
especially when it comes to undergraduate education.
Of course.
In undergraduate education, the idea is that that this is the only time when you have got all the fundamentals to be learned. Where now the thing on advanced students, how do advanced students learn? So if you have the passion on the topic, then you can do an undergraduate research internship. So that opportunity in your summers or during your school time to build upon your passion always exists. So it's not that you have completed one subject, it's a silo, and then you just shove it off. The idea here is that the person, after doing a particular course, should now start beginning to see the interconnections between two various concepts, and that synthesis takes time. So it took so I've been in the subject of chemical engineering for nearly about 20 years, and even I would say during half of my journey and after I did my PhD, then I started to understand that how different linkages are there, and that takes time, that takes practice, and that takes consistent work.
That was some
Sorry for the
very
interruption, but I thought that I wanted to make that point clear.
Yeah, of course. I think it was really important that you said what you said. I think you gave some really valuable advice to the students and also told us how, professors and teachers should be. So that was really great. And speaking of engineering questions and problems, they can sometimes seem unsurmountable. So how do you stay motivated to, maintain a positive mindset and push through even when you feel like this question cannot be solved, like that kind of feeling? So, what advice would you give to students struggling with similar issues?
Tejas, this happens, and in numerous engineering courses which I have dealt, this is often a problem. And why this problem occurs, let's understand this in a little bit more detail. The question why it becomes unsurmountable is that the question which has been framed has got number of components, and there is a weakness in one of the components because a complicated question has got many subparts and subtasks to it. So the role of the instructor, if they are doing an advanced course or they are teaching a concept which is quite integrate, The first thing, and I'm talking of the American system here, please take the help of a teaching assistant. Do not feel shy. That is the first role, that if you are able to, if you're not able to solve a homework assignment, please get in touch with them, is the first thing. Because that if you interact with them, then you will gain the confidence. Sometimes you may come across that the professor, you may not be able to approach the professor, so contact the teaching assistant. The teaching assistants have a wealth of experience in terms of how they can help similar students learn. So it is not only the student who is in isolation, there may be other students also. And we feel shy because whenever a person enters into an academic institution, especially with high grades and high achievements, and they come across a subject, then the first tendency is that something must be wrong with me. There must be what we call as the imposter syndrome. I do not fit in. So I want to use this opportunity that please, if you are in trouble, then the likelihood is very high that other people are also in the same boat. So and that is where the group study comes into picture, because then you come to know, okay, and then the second approach is that always request a professor that I did attend your class, and this can you please explain the concept once again to me. Most professors, I would say, are inclined in the students, because that's why they are in the business of teaching or educating, because they want their students to succeed. So should be able to help. Sometimes they are that approach doesn't work, because they may then what you need to do is go to a library, open a textbook, and try to do a solved example, which is similar to that. The moment you do, even if you start writing a solved example and start going through the steps, then you would come across many fundamentals which you will be able to address. So the question on unsurmountable, Tejas, is that it's in our mind that we make it unsurmountable. It only needs a little bit of more time than is desired. And during a course of an engineering or an undergraduate career, it is my sincere advice that do not take these grades as a reflection of your intellect. It is just an examination. Sometimes examinations go good, sometimes they are not good. There's a lot which is happening in a student's career. People who are doing work study, their work pressures may be high, they may be concerned about their family's health. So there may be instances that you don't get that perfect A or A minus, because it's a chance of circumstance also. So even if a person is not scoring well and is trying hard, please do not get discouraged. The second aspect is that if you score less, you always have an opportunity to bounce back in life, because of the and tremendous opportunities which researchers have. So this is the American part. I wanted to address that part. Now for the Indian students who are doing, because I'm talking of two education systems here. In India, the similar things also are there, but sometimes the teaching assistants or the professors may not be able to help. The solution there is have a LinkedIn account and try to ask the contemporaries how students in other countries are doing, or what is going on in different colleges, and have that database. So in India, we have got these online learning, which is called the national NPTEL. So you can do an NPTEL course, do an online learning course, and try to get that, because the two systems are different. So that's why I had to make that distinction in my talk here.
Yeah, of course. I think you really like very clearly highlighted what students have to do if they're in the American system or the Indian system. It's you've really given some valuable advice there. And I think that the imposter syndrome is something which like many people feel, like that, like maybe I'm the only one who's not getting this concept and not able to like solve a question or, understand something. But I think that, there might be others also, just like what you said, who are feeling the same way. So there's no reason to get demotivated. So,
And
let's,
Tejas, if I may just add one more point on imposter syndrome, because you have brought that topic, and I wanted, since we are having this conversation, particularly the population which is at risk is when we have to promote women in STEM, because what unfortunately happens especially in India, that it's a mobility issue. Some they are not able to access good teachers in classrooms because their families may not encourage them to go from one part of the city to the other. or access resources. Sometimes interacting with friends becomes an issue, and that is where, as an advisor from the Society of Women Engineers, which I have taken up this role. One of the things that I'm working on is that how can students who are studying in class grades 9 to 12 be connected with other students who are serving as mentors, so that they are able to address the imposter syndrome, and these stories have to be heard by women students particularly. Although this can happen with anyone, like it has happened with me also, but particularly when we come across various populations, then this is an important part.
Yeah, I think it's wonderful that you brought up the topic of women in STEM and like the fact that you're in Society of Women Engineers. I think it's really important to promote STEM fields like engineering and math for women as well because they also play a pivotal role in, even if you look at history, like all the discoveries and stuff, women have played a pivotal role. So let's move on to your role as a teacher. And how do you do you use any techniques to help students overcome their apprehensions about mathematics? And what strategies do you use as a teacher, to like simplify complex mathematical concepts?
Thanks, Tejas. So, the subjects in which I've taught, one thing is that whenever I'm explaining a derivation, I would try to give a computer interpretation also of that. I'm now privileged in this era that we have got a lot of open source software. So that open source software could be supplemented with my teaching. There are a lot of wonderful examples which are there, but the what which example to provide the context, that requires an educator. And now in this era, we have got a lot of access to to resources, a lot of information. The role of an educator now has evolved in helping the student assess that which resource has to be leveraged by her or him so that they can accelerate their understanding. There is a fear which I have in my heart, which I wanted to share on this podcast. That's why, although I'm not a mathematician, I'm just a learner, and which I wanted to utilize this opportunity, especially with mathematics researchers in the field of mathematical thought. The field of mathematics and its intersection with chemical engineering had a great boost between the 1910s to 1950s, particularly which we are evidencing today, because there was lack of computational infrastructure, so a lot of analytical techniques were being used in design. Now, with the advent of computational fluid dynamics, high performance computers, we now can do better resolutions. We can solve things faster, but and now also with the evolution of artificial intelligence and data science, we can now study old data sets. But the art of applying physical insight to a mathematical equation is under threat, in my personal opinion, because still we need the blackboards, we need the person to write through the problem, we need an understanding of the analytical steps, and that is an art that I'm worried about, that with the use of computation, a significant amount of computation, that may become a lost art, and especially in the next 20 years. So, because all of the advancements in chemical engineering, especially in analysis, have happened due to the application of these insights and particularly using all the fields of mathematics to a physical problem, whether it's related to energy, momentum, and mass transfer, and even a study of chemical reactions. So, how do we preserve that skill? That is where I wanted to mention about the old textbooks. How did the people in the past learn? This needs to be understood and inculcated along with our present understanding. So that is something that I wanted to share when it comes. So I'm trying to develop that balance over there, because in the during the next 20 years of my career, I'm really concerned about it, that do we have those people who would be appreciating those skills? Because the people whom I were taught now are in the 70s, and that is a lost art.
Yeah, so you think that, what you said was because of like the developments in computers and the easy access to it, the number of people who are using whiteboards and blackboards and like actually learning like the physical proofs and stuff, that is decreasing. And you think that that might be like a skill which might get lost in the future due to the increase in the number of, computer usage. So
Yes.
yeah, you also touched upon, the access of resources. I think I agree with you as well. We spoke about how, like it's the professor or teacher's job to guide the students to the right resources and ensure that they're learning from the best possible resource to enrich their knowledge. So let's talk about you spoke earlier in this podcast about how you collaborate different students with each other. So let's talk about how you foster it. And for example, if you have a math student and a chemical engineering student, how do you foster the collaboration between them? And can you share like an example of a student project? You spoke about group work, right? Do you have an example or a specific project where you saw the collaboration and that led to a success in the project?
Tejas, we do it in the classroom. For example, if there's a statistical problem, if I may say that there is an understanding that you have to calculate the standard deviation or the variance of a region experiencing high rainfall. So that is a problem which is related to a hydrologist. And the chemical engineer may use a similar problem statement to analyze the exit concentration in a reactor. Two different perspectives. So we focus on the concept, and then we help the two populations, the student populations, understand each other's perspective. Let them enter into a conversation that, okay, this is a problem of analyzing statistically, how it can be applied to your fields. The concept of statistical distribution, I'm just taking a very simplified example. What is the role of standard deviation? What is the role of variance? Civil engineers and chemical engineers may have a different perspective based on their experiences. However, air pollution could be an example where both are working on an environmental front and they're trying to measure polluted concentration, and chemical engineers are measuring reactant concentration. A civil engineer may come from a perspective on the fall of rainfall, which is a hydrological perspective, and a chemical engineer may be concerned about what is the concentration in the exit reactor, which is the residence time distribution theory. So when people start, they are studying the same subject, but the interpretations and experiences are different. So we sometimes form a problem statement and have them discuss with each other. And then we ask that, okay, this is a normal distribution. Where do you study and how do you apply it in your own field? And this helps in giving a diversified perspective. So that is the stochastic part. Another interesting example is that my PhD was in chemical looping combustion. Now, combustion as a discipline is essentially, I would say, has a chemical reaction which is used to provide energy. Now,
Yeah.
a mechanical engineering perspective on combustion is when you're designing engines. How do you analyze the generation of power? And a chemical engineer's perspective is how to design an equipment which generates that energy. So there are opportunities in both disciplines where things really become interdisciplinary. For another instance could be that data scientists who wish to analyze the concentration of beer which is coming out of the brewery, and what is the effect of the hops which are being used to generate barley, that alcohol content and its fermentation. And so there's an intersection between data scientists who are working on science and chemical engineers. So during the classroom and during our interactions as students, if we are able to bring out those examples rather than just delivering the content, you can learn a lot from the various perspectives the learners are coming from. So definitely delivery of content is there, but also some part if it's devoted to discussion and reflection, you may never know that how enriched your class may turn out to be. It's just
Yeah,
it's just similar to what I learned when I did a business school course that you use the case study method. So some elements of that.
yeah, I think that's wonderful to hear. Like I agree with you in the way you said about how like different people concentrating in different fields will have different perspectives on questions. You gave the example of a chemical engineer and then like looking at combustion versus a mechanical engineer. So I think that what fostering collaboration does is it gives different angles on how to solve problems. So like a mathematician might think differently from an engineer, and I think that would give more ideas to the group. So I think it's like a great way of learning, and group projects again, I think is really important. So now let's move on to like a slightly different topic. The 1900s were a period of, a lot of mathematical discoveries, right? Do you think there were any specific mathematical discoveries or inventions which helped shape chemical engineering and made it what it is right now?
Thanks, Tejas. And this period is very interesting in human history because, unfortunately, chemical engineering, its development was fueled by two wars, the World War One and World War Two, in different areas. So around the First World War, the center of focus of chemical engineering, which was evolving from industrial chemistry, was Germany. And the development of high pressure reactors, particularly the synthesis of ammonia by Fritz Haber and Karl Bosch, is a landmark event in terms of that how you can use you can essentially through the ammonia molecule introduce atmospheric hydrogen and bring it back to the soil, and it led to the production of fertilizers. Now, very interesting things happened in the 1920s era. I would name a few scientists: Edward Teller, an Hungarian. Then there was Linus Pauling. They all had their fundamental training in chemical engineering. Edward Teller was a famous nuclear physicist. Linus Pauling was a famous chemist. But their basic degrees were in chemical engineering because chemical engineering was considered to be a pathway towards developing towards prosperity. So now, when you have got a field where you are able to attract the best talent, and also picture the 1900s and 1920s, it was the advent of quantum theory. Max Planck, Albert Einstein, Arnold Sommerfeld, Paul Ehrenfest, and the literature of that period, Enrico Fermi on that matter also, they were getting trained, and especially if we see the literature on science, then the role that Paul Ehrenfest and Arnold Sommerfeld played as teachers was simply remarkable. So that was an era where thought processes, scientific thought was really fostered to the maximal limits. Then another phase comes in chemical engineering when in the 1940s with the development of fluidized bed catalytic reactor, which was used to which was used to synthesize large amount of gasoline which was used to fuel aircraft because there was no source of fuel because of the World War II. That also led to numerous developments, and this was the pre-computing era where mathematics was used liberally, was used in great insight, and the literature from that period gives a lot of especially particularly in terms of design, brings the best of human creativity. And then I would also, they just recommend, because since you are in applied math and your audience may be in that area, a wonderful review by Professor Doraiswamy Ramakrishna and Neil Amundsen, titled Mathematics and Chemical Engineering of 50 Years Introspective, which gives in detail a lot of information on how mathematical methods have influenced chemical engineering. Although it has been 20 years since the article was published, it's a 2004 article, but that article is highly relevant today because that acts as a bridge between understanding different generations. So, and there are others also, but I would particularly point out that one. So that is where the period between 1900s to 1950s, the pre-computing era, and then the use of engineering physics and engineering science and the use of applied math, you could see some brilliant examples over there.
Okay, so in the 1900s, you spoke about several like inventions like the catalytic reactor, and how you spoke about gasoline and stuff, and you gave an example of uh, several mathematicians and chemists, and how their works intersected together, and that chemical engineering was a really prosperous field in the 20th century. So let's move on to applied mathematics, which you just spoke about. Many of our viewers would be, like really looking to apply math to several fields, and they'll be looking to bridge the gap between theory and practice to see how mathematical concepts or applied to real world scenarios. So could you share a project or a case study which you were involved in where, the intersection of mathematics and chemistry led to a breakthrough in your work? Was there any specific project where, this happened?
So Tejas, I would not say the word breakthrough, but I would say in my case it was re-exploring and investigating the utility of applied math or even mathematical ideas to a recent problem of interest. So my doctoral work was essentially involved with doing the process design of a process which is called chemical looping combustion. So the idea is that you have got a reactor in which instead of burning coal and pure air, the idea was that you could have a copper oxide particle release the oxygen through decomposition into cuprous oxide, and that oxygen would be used to burn a carbonaceous particle. The key work was done by Professor Henrik Leon in Chalmers University, and he had some excellent experimental results. But what was required at that particular point in time was that how those results could be analyzed mathematically. Now, there's no, before my work, there was no mathematical background which was available, which would be used directly to the process. I was tremendously fortunate that I was mentored by Professor Adil Seraphim and Professor Joan Lighty. And so Professor Adil Seraphim was a chemical engineer from MIT, and his ideas were pivotal in understanding coal processes, that how does coal burn, coal devolatilization processes. So he was a presidential professor during that time. And the base, and so we were just trying to search out the literature, and I came across a 1951 article. This is, we are talking of 2008, which had the process which was given, and it had the raw data that we needed. So now the question was that neither I have been taught by those academicians, but Professor Seraphim was learned from one of those academicians who wrote that paper, Professor Warren Lewis. So he knew that how, now this is implicit knowledge. That if you have been taught by a professor who writes a paper, so you understand what they are talking about. So he helped me understand the experimental data, and that how should I interpret that data. So that interpretations were done by him. Then I used a very simple quadratic equation to model out the scenario. But how that quadratic equation had to be formulated by taking the physics of the burning process and the kinetics of the cupric oxide process. That was the foundational paper which began a series of investigations into that process, because you need that one starting point, or what I would say, a spark. Then, because you have got all the advanced methods in the world which are available, but if you don't know where to make that beginning, how to interrelate the different physical phenomena, the mathematical tools are available. But if you don't know what is the physics of the process, what is happening in the background, how do you link a burning of a coal particle, where do you find the combustion kinetics, where we define the kinetics associated with decomposition. The problem was simply, and that's why I was able to. This was one of the stepping stones to earning a PhD. So that was, and then that simple analysis then led to many multi-million dollar grants at the University of Utah, because they were able to conceptualize that design, and the work has continued since I graduated after 2013. So the key point that I wish to make is that people who could help you understand what do certain um, researchers have achieved. It's uh, if I may say that the doctoral advisors and professors play a very important role in helping students to think and to teach. I was taught how to think, and that's what I'm trying to do with other students, because I've had this experience firsthand. And coming to another example over there, so this was the combustion side. The oxidation side was done by Professor Hong Yong Son, another luminary in the area of gas-solid reactions. I took his classes on gas-solid reactions, and he helped me understand the copper side. So I was benefited by working under the tutelage of three outstanding professors, and that has helped me in my career. That has helped advance the field And now I'm doing the same thing. It's a similar situation. I have a research scholar who's working on analysis of hydrogen blending in natural gas infrastructure. The same situation is there. The work was done in 1960s. We are reinvestigating the work and we are deriving some fascinating insights. So this is a continuing story, Tejas.
Wow, that's really unbelievable to see, that your work led to multi-million dollar grants. And also, I think you again stressed upon the importance of good teachers and professors because they only teach you the way to think. And also about mathematics, I think that what you really stressed upon was that if you're an engineer, you must have a solid mathematical background, but that is not enough. You need to know the physical concepts and, like all the chemical elements as well before, like taking on a project. You can't just have a little bit of each. You have to have a good understanding of the topic in all three fields. So I think that that was some really valuable advice. And speaking of engineers, there were some interesting statistics that I saw that in the US, about 50% of engineering majors changed their field of study during their freshman year, and 25% of engineering graduates don't actually work in engineering, and only 25% end up working in engineering related fields. So I think that this raises like a really important question, right? So what do you think is the reason that makes fields like engineering and mathematics so hard and like perceived as difficult compared to like other majors or other fields of study? What do you think sets these fields apart?
Tejas, I'm now my perspective is influenced because I'm now in India. So the situation in the United States, the only comment which I like to make is that where these students are going, are they going to finance, are they going into data analytics or software, or because the engineering fields, the salaries, and how do they compare with those areas, especially computing, and why so the situation could be different in both countries. So I need to have a little bit more perspective because it has been about 10 years, sorry, 7 years or so, and there has been a numerous changes which have happened in terms of what is happening in the United States. So I just need to update myself on that. But when it comes to the Indian perspective, a very interesting thing has happened that India is having a lot of emphasis on the information technology, the data science industry, and the artificial intelligence industry. But there is a silent revolution which is happening in terms of manufacturing. Especially in chemical engineering, there's a lot of manufacturing capacity which is expected to come in the next 5 to 7 years. And it is my belief that we may fall short of chemical engineers. There are indirect evidences right now because we are not getting enough graduate students who are having a bachelor's in chemical engineering in our master's program and doctoral programs to that number. And so there's a lot of influx from other fields. So the situation in India is quite interesting. And every country, I recently visited Indonesia, and their concern was that they are also having a lack of engineers who are entering into the field because their students are going into finance. And so one thing that I would also like to share with any person who's listening to this podcast is that perhaps it's a high opportunity that every country does its skills analysis. That what is the requirement of engineers? Are we having enough graduates? And through now LinkedIn and analytics that can be used, I think that should be an easier decision for many countries. The US does a wonderful job in having these national Science Foundation and the National Academy of Engineering surveys, and other countries may learn from those.
Okay, yeah. So even I agree. I think it's really important for, like the number of engineers to stay high because of the value they provide. And you spoke about many countries like Indonesia, for example, where the number of engineers are decreasing due to the, like rise in supply of finance students. So yeah, I think it's really important for engineers to stay. And let's talk about finally like IIT Ropar, where you've been instrumental in shaping the academic environment there. And what innovations or changes have you made to, like emphasize the importance of mathematics in engineering fields to your students?
So Tejas, I would not like to take the credit on mathematics. I am just sharing a perspective over here. My influence primarily has been to promote students in STEM fields. So I was working as the head professional development, and when I came over here, I felt that there was a greater need to connect with students in other parts of the world. Where I was fortunate, I was able to build those bridges. And then The second initiative was the Student Society of Women Engineers that I have been a part of, where I have helped many women students. The third initiative, which is not linked to IIT Ropar per se, but I use the IIT Ropar platform being an educator, is to help other students from different universities across the nation, even abroad for that matter, to help experience a good technical institution like ours. Through internship programs, through virtual internship programs. Also, there's a signature initiative that we are doing, which is called the Energy Mentors Program, along with my colleague, Dr. Dheeraj Majan. So recently we had about 70 students who have been trained virtually. We give them a problem and then we help them mentor, and they try to come up with innovative solutions. And also, I would like to mention Mr. Don Victory, who has been an amazing support to us. And the fifth thing, which I'm really happy about it being at IIT Ropar, is my participation as a mentor in solar decathlon. It's primarily having this interdisciplinary collaboration with civil engineers, chemical engineers, as well as on the field of energy. In summary, mathematics does play an important role. I do teach a few courses which have a math background. So there is an indirect influence, but I would give credit to my colleagues in the mathematics department who are doing a far more greater job, and definitely would encourage some of them to be a part of a podcast.
Of course. I think you also touched upon briefly on internships. I think those are also really important for students to, put their like theoretical knowledge into like a practical application by working in industry or wherever they want for engineers. So yeah, I think a real world skill set is also important for, like college students or graduate students. So thank you so much for joining us today and sharing your valuable insights. Your perspectives on the role of mathematics in chemistry and other engineering fields have been really inspirational for our audience. To our viewers, thank you so much for tuning in to this insightful conversation. If you want more conversations like this, please make sure you like, subscribe, and if you have any questions, please make sure to leave it in the comment section below, and I'll definitely reply to it. Thank you so much.